In July 2013, Nilson Barbosa and Leal, two Brazilian inventors, unveiled a series of patents that have ignited significant interest in the field of energy generation. At the forefront is their patent WO 2013-104042, titled Electromagnetic Device for Capturing Electrons from the Ground to Generate Electricity. This groundbreaking patent outlines a simple yet ingenious electron trap device that challenges conventional methods of energy production. The heart of Barbosa and Leal's invention lies in its continuous conductive loop, where current flows persistently without the need for an applied voltage. Unlike traditional generators, the magnetic fields of electromagnets maintain the flow of current, creating a self-sustaining system. The inventors assert that even a minute input power can yield a substantial power output, suggesting a coefficient of performance, COP, of at least 100, a ratio of 1 watt input generating 100 watts output. Barbosa and Leal's patent introduces an electromagnetic device designed to capture electrons from the ground, paving the way for a revolutionary approach to electricity generation. The following exploration delves into the patent's intricacies and effects, shedding light on the potential to simplify the complex enigma of electrical energy generation. The patent's most extraordinary element is its innovative ground connection approach. The winding of a typical wire around another copper wire, without forming a direct metal-to-metal contact, challenges conventional wisdom. This configuration, as detailed in the Practical Guide to Free Energy Devices, demonstrates that there are alternative ways to approach electrical connectivity.
Hello YouTube, I want to bring to your attention this patent by Barbosa and Leal, and it's patent number WO2013104042. The electromagnetic device for capturing electrons from the ground to generate electricity. So it's a very simple device, as you can see, and I want to point out something very strange. Look at this ground connection. So you just have a wire wound around another copper wire with no metal-to-metal connection. And this patent is in the Practical Guide to Free Energy, page 213, section 330. So I have a schematic for it right here. And this is the device. So it resembles a bi-tori transformer. So I have two coils. One is 10 winds, the other one is only 3 winds. And the negative, it's supplied with the DC power source, and negative is our negative, and our positive is from the ground. And see, we're getting AC, 3.7 AC. And this is our notice this is a 4-gauge copper rod that I have wound with a copper wire on top of it. There's no metal-to-metal connection anywhere, so the connection is done through induction. And so this ground connection is connected to my house ground. My house ground up there, and as you can see, there's no metal-to-metal connection. So this is a loose coupled wire. See, these windings are very loose, connected to each other, and this is what the ground is connected to. And the thick copper wire is just connected to the shorted out coil. So there's two coils in here. One is powered with DC, and the two loops is just shorted out with this thick wire in the middle, wound with the ground. And we're getting voltage. See, 3.7 AC. But see what happens when we disconnect our ground connection. So okay, sorry about that. Okay, so we're gonna disconnect the ground. Okay, as you can see, the voltage drops. Now it's 2.3 AC. Okay, now we're gonna connect the ground again. Okay, 3.7 AC. But this ground is not physically connected in terms of, it's not metal to metal connection. So you're actually inducing, so it's copper on top of copper. It's a thick copper wire wound with more copper on top of it. I've never seen that before, and I didn't imagine that this would work. And I just came across this Barbosa patent, and I was going to check it out. And in their patent they have one that looks just like this schematic, and another schematic they have this plus and this plus connected through a connector. And so there will be like an extra connector right there, and I couldn't really achieve anything with that setup. So I'm showing you a strange effect that I got with using the unpolarized version. And this patent is in Brazilian, but you can use Google Translate to actually translate it in English or whatever other language you happen to be working with. And I found it rather curious, as you can see. So the curious part for me is that if you disconnect this ground that's loosely connected, the voltage goes down, see, instantly. So to me, this effect alone warrants further investigation. And I hope you guys enjoyed this video, and I'm going to be playing around with this some more, maybe combining this effect with Adley-Skelman's PMH, see if I can draw voltage from the ground. So I have this mesh over here. This is just a aluminum screen mesh, and in the Barbosa patent, the Barbosa and Leal patent, they recommend that this ground connection would be some kind of conductive mesh buried deep in the ground. And I just have this conductive mesh. It's a screen, aluminum screen for your porch. And I'm going to disconnect my house ground and connect it to this, and we're going to see the voltage. So right now it's at 3.76 volts. So I'm going to disconnect my house ground, and I'm going to connect it to this mesh over here. Okay, let's see. Okay, so it's 3.47 volts now. So obviously it's not really well grounded. It's just laying on top of my floor. So I would imagine if I happen to bury this in the earth, it would be grounded a lot better, and the voltage would spike. So anyway, this patent is rather curious. It definitely piqued my interest, and I hope you guys will investigate the practical guide to free energy devices, a PDF, and look at this patent. And I'm going to continue